Thank you very much for staying out here. It's an important and interesting topic. As we heard from the speakers before, heating and cooling. And in this context, I'm talking about heating for the sake of heating because we need it in industries as well. And one of the contributors of CO2 emission is burning fuels, most of which is used for heating in the industries. To put it in perspective, globally, about 100,000 terawatt hours of energy is used, which includes electricity and heat. And of which 50,000 terawatt hours is used for heating, putting both, I would say, domestic and industrial heating together. And most of it comes from burning fuels. Whichever country, wherever you go, natural gas is so cheap, they burn natural gas, which is fairly efficient, but still contributes to the CO2 emissions. And in India, almost 49,000 million tons of oil equivalent is used by the industry, which quite a bit goes towards burning. Similarly, you look at cooling. We talked about cooling and as a problem, heat stress and so on. And obviously one of the first thing any community or any person would do as they become upwardly mobile in terms of income and so on is buy an air conditioner. As of now, the air conditioner penetration rate in India is about 9%, which is fairly small, contributing to about 2% on the electricity on the grid. This is likely to grow to about 9% of the electricity on the grid in another 7 years, and to about 50% of our peak demand by the time India becomes Viksit Bharat 2047, which is a huge stress on the grid. 800 gigawatts is the expected capacity on the grid. And you can imagine 50% of that peak load is going to be for cooling. So this cannot happen the way it can happen right now. You cannot buy an air conditioner, put it in your house and have cooling for yourself. It cannot happen. There has to be innovation, there has to be collective action, and there has to be acceleration. I'm pleased to have my esteemed panelists with me. I'm Professor Satya Seshadri. I'm a faculty at Applied Mechanics at IIT Madras. I mostly work on heating and cooling. That's my bread and butter. I'm fascinated by the fact that we consume so much energy that we end up dissipating from a pure thermodynamic perspective. We take all the highest quality energy that is ever available, burn them and throw them out. That's the worst form of conversion that we can ever do. But that's the best we know anyway because Rajneesh nicely summarized because the energy that comes is very cheap. So we use it in the most ineffective way as possible. So with me, I have great panelists here. We have Rajesh from Danfoss, who in a sense represents the company that provides us the technology that is required for creation of this environment that we have. We have Vikas from Blue Star, who has been, the company is quite well known in India for providing air conditioning both at a domestic level and a consumer level. And also, I would say, at an important crossroad in saying and helping us navigate this journey, we have ESL, Mr. Girija Shankar, whom I know quite well. We've been working together on understanding and helping electrification of heating, particularly in places like Ladakh, where they've been using diesel to produce the heat and see how we can use the abundant renewable energy and implement technologies that can mitigate it. And they've also quite known in India for bringing down the cost of LEDs, and they have done so with BLDCs. And we have Archa from Tabreed, who is introducing a concept of, it's quite well known across the world, at least in places like Middle East, where you have district cooling. Singapore is quite known. In India, we are struggling to do, and probably she can share some insights on how this will go. So, having that context, maybe I will start with Mr. Rajesh with a certain set of questions where if you can tell us what concrete actions are required for increasing sustainability in cooling and who are the necessary stakeholders. Of course, as I said, it's a large, complex problem. So maybe if you can take from your perspective, what does it mean to improve the sustainability and what should be the goalposts?
Hello. Thank you, Professor. Good morning, everyone. I am Rajesh Tella. I am from Danfoss. I would take you all back a little, few years back, while we talked to a lot of industry leaders, we used to talk about cooling in the past, only cooling. And then now when I go to meet multiple customers, I talk about not just cooling, heating actually as one of the important part in the whole spectrum. Today, we are talking about integrated solutions, which is about heating and cooling. It is not just heating alone or cooling alone. Like what Professor had said initially, if you talk only about heating, you burn the fossil fuels and you just leave it to the atmosphere. But whereas if you talk about heating and cooling, and I think that is one area wherein we all need to focus, Professor, because as you indicated earlier, the demand on cooling is going to be 50% of the overall demand. And if you've seen earlier by Mr. Agnihotri in his presentation, the India Cooling Action Plan indicates about 25 to 40% reduction of the cooling load on the grid, which accounts to approximately, if I'm not wrong, around 100 gigawatts. That itself is a big amount right now. I mean, and if you ask any investors or economists, I think this is where everybody would like to focus. So right now, what I see is, I mean, let's come to the basic things, what we see at our offices. We see ducted air conditioners outside our offices. We see a lot of chillers outside our offices. One important question which we can ask ourselves is like, are we getting the right output from it? Is it only cooling, or are we combining that with heating? That is something which we should ask each one of us. We should ask ourselves right now to get the best output from the current solutions. I think that's where the action starts, Professor.
Thank you, Rajesh. Now, one challenge, as we just heard, because if we prioritize, say, cooling, heating is thrown out as a byproduct, and there is no clear way of using it. And if we prioritize heating, cooling is just made available, and maybe we don't know how to use it. Probably I'll switch over to Archa here, who has been working on district cooling, which kind of allows, in my opinion, a little bit of aggregation of either heating or cooling. We can also switch to district heating or some other form. How does that work? And can you tell me a bit on, in the context of India, what kind of challenges we see and what might be the solutions to scale?
So maybe I'll first just explain a little bit on how district cooling works and what do we mean by aggregation of cooling demand. It is happening in some sense at IIT Madras Research Park already. There are multiple buildings that we see. Each of these buildings could have had a split or a window air conditioner. They have, each room has some cooling demand. But instead of having split or package units in each of the rooms, what IIT Madras Research Park has done is they've aggregated the cooling demand across all buildings, set up a centralized plant which serves or caters to the cooling demand of each one of these buildings. Now, what is the benefit of centralizing this cooling demand? Because of the diversity of usage, one of the research rooms might use cooling or need cooling during the day from say 6 to 11, another one at night. You are able to cater to the cooling demand of these diverse rooms using the same equipment. So in effect, if you were instead of putting, say, 1,000 tons that you would have required for each of these buildings, you've reduced this down to 700 tons, for instance. The diversity benefit could go down as much as 40–50% in some cases, depending on what kind of end uses are we mixing up. For instance, if there's hotels and malls alongside commercial offices or residential needs cooling at night, offices need cooling during the day, we can have the same equipment meeting the cooling needs of both an office park as well as a residential complex. How does this impact the grid? You've shaved, like I think Anson was mentioning yesterday, I don't know how many of you were present. One of the biggest component is the fixed power demand, right? You have to ask the grid to give you so much power demand so that you can meet your cooling need. But by reducing the cooling or the mechanical load, you've already reduced the power demand that you have from the grid. So yes, sure, substituting renewable with fossil fuel is one way, but why don't we just reduce the amount of energy we need as the first step so that our material footprint also reduces significantly? There are several other benefits in terms of it being more efficient in terms of energy consumption. Of course, associated emissions are lower, capex is lower, and so on. We can talk about that offline if you're interested. In context of India, we've seen some headway. Tabreed was awarded a project for the Amravati government complex, which is being built in Andhra Pradesh. unfortunately, not a lot of progress has been made yet. In Hyderabad Pharma City as well, Tabriz was awarded a project. This is Asia's largest PPP-based district cooling concession, 125,000 tons. So all of this is happening, but the progress is quite slow. We believe this is a lot because of the mindset issue. We are very comfortable where we are sitting. If something works, why change it, right? I mean, we can all have split ACs, window ACs. Why bother going through this headache, changing this whole system? I mean, it's not immediately obvious to a lot of stakeholders in this ecosystem on how to go about installing it. So why change it? Why bother understanding how does it help me as an individual? It doesn't maybe. I mean, we are so short-sighted that we don't look at the long-term focus. So it's more, I think, about the awareness, about moving away from that inertia, where I see the challenge.
So I see problems more than that, because district cooling, as we have all known about, multiple district utilities requires public access right of way, which seemingly is a problem in every case in India. It's kind of ways by which you may be installing a solution, a pipeline and so on, but who maintains and how do you ensure the efficiency gains are delivered and continue to deliver is one thing. But let me switch to Sri Girija Shankar, where EESL as an entity set up to drive efficiency in the country has been phenomenally successful in the LED, now replicating that with the BLDC fan. Have also tried a little bit with the air conditioner. Now maybe Sri Girija Shankar, if you can understand and if you can explain or help us understand what could drive this cooling revolution and what could be a potential impact on the grid if we were to project ourselves.
Good morning to all. Myself Girija Shankar. I am General Manager in Energy Efficiency Services Limited. Earlier speaker, I think the Professor Rajneesh has set a context that what are the sectors who are responsible or creating maybe the CO2. So if we see that, what's your question is that which are the drivers? In the slide of Professor Rajneesh, we can see that if we combine, maybe cumulated, total footprint of the CO2 from the various sectors or maybe by various measures we can see. So around more than 50% of CO2 mitigation can be happen through the energy efficiency. And energy efficiency is a tool where everyone get benefited. There is there may be a small investment, but it will provide opportunity sharing to various sectors. So in the journey of our LED lighting, when the Prime Minister has initiated this program in 2016, the first tender comes up with the rate of around 380 rupees, 7-watt LED bulb. Within a 2 years time span, this rates on account of the aggregation of demand from the various sectors, from various clients, and also getting the confidence from the manufacturers. So we are able to reduce down about 1/10 of that cost. So around the bidding, which I think that the fourth stage has happened, 38 rupees 7-watt LED lamps we have able to arrive. But every element or every technology have their own, I think, dimensions. And any economic activities, they also have their own multiple dimension. If you want to maybe the same kind of intervention or maybe reduction, it cannot be happen. LED have maybe the material component is very small. But in case of maybe the chillers or maybe the air conditioners, the material component is too much, maybe about more than 50% is from the material side. Reduction in the cost of material less likely to be happen, but there are various parameters or maybe the type of intervention by which we can create maybe market solution. You highlighted and also in the earlier one presentation by Rahul, they highlighted that around 8 times of this maybe the cooling requirement, or particularly the energy demand is going to be happen. So it is not only that we can able to provide access to cooling, but to provide the energy to run the, I think, operations of the air conditioning system, That is one of the biggest challenge. Being as a developing country, one side we have that we have to increase our economy. On the second side, we also have to make more sustainable. We have to more conscious on the CO2 part or other consequences which are likely to be happen on account of the climate change. One of the major, I think, the intervention which can be able to create or maybe transform the market is that the business model. If we can create the business model, what Archana is just mentioning that, if we can maybe diversify your demand for a particular campus, for a particular, I think the localized city or a small level of city, there are enough opportunity that the single unit can provide on account of the diversifying load patterns of requirement of the cooling. We are currently working with the IIT Delhi, and we are hoping that the one feasibility study we can able to provide where the district cooling like the options can be happen. Three, I think the Department of Electrical, Mechanical and other supporting activity they are providing to support, and once we maybe come up with the findings of those type of results, then in particular campus where the hostels may be operating or having the cooling demand in only the night time, academic blocks or the classrooms, they have the major cooling demand in the daytime. So diversification or opportunity sharing of the whatever the infrastructure we have, that will able to do. Second, if we can maybe create some market. So now ESL is working on this cooling as a service model. We also hired one agency, PwC, so they have come out with the what type of the 3 or 4 maybe options, the business model and the financial modeling of this cooling as a service. So we are working with the Anna University. We also recently conducted around 5 big stadium in Delhi. And the total TR requirement is around more than 2000 TR. In the similar manner, we are also working with the industry. So in the industry, I think the large part, the waste heat recovery is availability. If we can able to convert that waste heat recovery which is available, and that can be reutilized for maybe space cooling or the process cooling requirement within the campus or maybe the plant boundaries, that will provide a good opportunity, and it will also reduce down the cost, because it is only you have to just capture the waste heat recovery and reutilize in your process. It will enhance your energy efficiency improvement. So there are multi-dimensional by which we can able to do. Second is that because many organizations like the UNEP and the other AEEE, Bureau of Energy Efficiency, IIT Madras, and many other organizations, they are also providing awareness, maybe what kind of design guidelines we can be work on. So with your help, we are also working with the support of UNEP to develop the design guidelines for the heat pump technology. And this heat pump is not only just for the space cooling or heating, it can be also utilized majorly in the industrial domain, where the larger amount of, I think, the CO2 mitigation we can able to reduce down. Recently, we also, last year, we have got awarded one Asia Low Carbon Building Project. In Asia Low Carbon Building Project, it is funded from the IKI, the German government, and GGI, ACE and HEAT. These 3 are the partner in this one, and we are targeting the 3 states. And around 100 cooling projects we are targeting with next 3 years. And not only these pilot of 100, but we are also going to replicate in the other state, apart from these 3, Kerala, Uttar Pradesh, and Haryana. So in the similar manner, if we can maybe able to create a very large market, which provide maybe opportunity sharing to the technology solution providers, IT companies, being as I think India is well known in the IT solutions. And your center and also some startup companies in your research parks, they have very good solutions. So any air conditioning, if you can measure and able to control, 10 to 15% savings you can able to achieve. So these type of, I think, multiple dimensional approach, and the factors which have some correlation with the taxonomy of cooling, if they all needs to be integrated and comprehensively may be integrated in such a manner that it will provide opportunity sharing and cost saving, then this maybe market can be booms up, and any stakeholder or the client, they can get a better attractive offer.
Sure. Thanks. Thank you very much for laying out some of the strategies we could follow. One key challenge, though, as we spoke about, this is a big problem and opportunity, and we almost always face the availability of systems and components. Now, maybe I would like to ask Mr. Vikas, who's from Blue Star, to see, since we see this as a large market opportunity as well, and as a company, how do you see the component ecosystem growing? I mean, as we already know, the core component and core technology in any cooling system that is mature right now is the compressor, and any control we might have on improving efficiency is through the component ecosystem. So how do you see that, and do you see a role where India starts becoming a major manufacturer of these components? Because I do see, besides the typical critical technologies, people talk about AI and so on, I do see these as some of the critical technologies, because without addressing them, we aren't able to progress much. Maybe Vikas.
Thank you, Dr. Shadri. It's a wonderful question, and I would like to touch upon few areas in that. First is that when government came with a regulation that we should stop importing of air conditioners. So at that time, around 25 to 30% of the air conditioners were being imported. So that was a big challenge for the industry, wherein there was not that much of an ecosystem. But then government came with a scheme of PLI scheme. So as in what is happening as of now, like Siri City is one of the places where almost more than 10,000 crore rupees of investment has already been done by the HVAC companies, wherein to really make that ecosystem self-sustaining. So when we started this journey way back in 2021, I would say the bill of materials in that the localization part was just around 15 to 20 or 25%. But with heavy investment by all the players, that localization has come to 45%, and the idea is that up till year 2028, that localization will go up to 80%. And I think I would presume that maybe in maybe 2030 or so, we may be having a fully indigenous air conditioners. Talking about primarily about the compressors, Professor. The problem is that in case of compressors, way back in 2021, I think around 90% of the compressors were primarily imported, and that was the biggest challenge. Now the main issue about the compressors is that it's highly technology driven. You have lot many patents into it, and you need a heavy investment in this. And the another problem is that there is no SME base in that. So, and to typically have a running manufacturing for a compressor, you at least need 2 million units which can be sold in that particular plant. So with those challenges in mind, but yeah, still with that PLI scheme and all, I think many companies are even starting those compressor manufacturing plants in India too. Yeah.
Thank you. Thank you very much. And I think this kind of brings a critical problem in which the core value addition and the reason to drive innovation, because as I said, I will also throw in one more statistic, because we talked about gigatons. From a gigaton perspective, heating and cooling, up to 200 degrees centigrade, where currently heating could potentially be supplied through heat pumps and the technologies that are driven by the vapor compression technology that we have right now, contributes to about 1.5 gigaton of CO2 reduction opportunity. Then, if you look at cooling and driving cooling efficiency from the current baseline, dependent on whatever is available that is currently most mature in the market, we have about 1.6 gigaton of CO2 emission directly contributed because of the systems on the grid. And even if we are to achieve a 30% reduction and projected CAGR of about 7 to 8% on all the air conditioners, that presents another gigaton opportunity of CO2 reduction in the next 10 years. So given the magnitude of the problem, given the size of the opportunity, what would and what should the ecosystem that you are in here? I just want one response from each of you to say, what should this ecosystem here do to seize this opportunity? Because on two fronts, one, this is the possibly the only economically viable carbon mitigation opportunity. In every other thing, CO2 capture and everything, you pay a penalty. Here is the only opportunity where you can have the cake and also eat it and still benefit. So I want one from each of you to say what is that opportunity that we should target as an ecosystem to really make it happen here. Maybe from Rajesh.
Thank you, Professor. I think as I said earlier, if I have to mention only one point, that we have to integrate both heating and cooling to the core. We should not let any energy get
I
wasted.
want your response to say what should this ecosystem, these are all people who are interested in the problem. So I want your answer to say what should this ecosystem do?
So right now, if you ask me, I think right now the whatever heat pump solutions what we have are a little bit on a higher side on the cost. But I think this ecosystem sitting here is a vast, it's a diverse ecosystem. And what we can do is like invest in the R&D which can make these solutions more and more viable and economical for the people to invest in and come forward and invest in. And if I may add one more thing.
Yes.
I think a lot of people are from the government as well as from the UNEP also. One important thing which has to happen is fast tracking on the policy part. I know the policy, government is actually taking very good steps, but I think fast tracking will actually help in quick adoption into the society as well.
Thank you, Rajesh. Maybe Vikas.
Yeah, so firstly, I would address students because they are also part of the ecosystem.
Of
I would
course.
suggest that you should be fearless and don't lose hope actually. So together with industry, academia and all the support system, I think we can achieve it. Second is that I would say we really need to promote as in sustainability part. What we can do is that if I talk about the split air conditioners, as of now, only 19% of the air conditioners which are being purchased by the customers are 5-star. So that means almost 81% of the products which are being purchased by the customers, they are 3-star.
So that's such a low-hanging fruit. Maybe we should mandate that we need to only purchase 5-star, but that goes back to Rajnish's point where you have to use it for a certain amount of time to derive the benefit of the savings that you use because of the 5-star. So anyway.
सर मैं जस्ट एक चीज़ कहना चाहूँगा, यदि हम मतलब एक कहावत कहते हैं कि मधु वहीं होती है जहाँ मधुमक्खियाँ वहीं चारों ओर रहती है जहाँ मधु हो. यदि आप अपॉर्चुनिटी दे सकते हो, इफ़ यू कैन एबल टू शेयर द अपॉर्चुनिटी, whether it may be the revenue for any startup company, whether it may be the I think employment opportunity, or maybe future career opportunity for the students, whether it may be the research where I think you all guys maybe have very knowledgeful base here. So all these may create a business opportunity for the various startup companies, for the various maybe faculty members or maybe the students. If all have that, if they are going to have the growth element, then most of the projects are going to be happen. We had seen this in the renewable part because the renewable is a capital intensive and very large growth element they have. Energy efficiency, although being as a very low cost, but it does not, it have a very limited revenue bandwidth. So if you can create maybe large pipeline, then all solution, maybe the PLI scheme can also be able to create this one. And any maybe consulting agency or maybe the manufacturing or technology solution provider, they will also see that there are business opportunities, we should also intervene. I give the one study we have carried out under the USAID support. So there is a projection that around 4.3 million tonnage refrigeration-based air chillers are going to be superannuated by 2030. This is only the volume of the 1 decade. So India have very large demographic, I think, opportunity to whether it may be the manufacturer or the
I think he has given an interesting, so we are going to retire so many air conditioners. So to all the researchers out here and our startups, there's an opportunity. Maybe for you, I have a slightly different question. So I think district cooling ideally supports cooling as a service kind of business model. But anything beyond electricity has never been successfully commoditized in India. Do you feel cooling as a service time has come?
Absolutely, the time has come, and I think Sudha ma'am mentioned how heat is recognized as a disaster in Chennai. Why can't we recognize cooling as a utility same as gas, same as electricity? Lay out the pipelines, solve the challenge for right of way. Why are we as citizens not empowered enough to demand from our developers, from our builders, that we really want a green, clean building, not net zero in name, but net zero in action? It's as simple as that. It is possible, it is happening. We just need to ask for it, demand.
Thank you, thank you. I think that's a nice way to put the premium and put the onus on the builders to say, now you need to have, just like now all rooftops need to have some kind of solar PV in India to get in Chennai to get the completion certificate. Maybe it is time to say all buildings above maybe 10 households or 15 households should have district cooling, and maybe a plumbed heating system, so that you cannot install your own AC and you cannot install your own geysers. That could potentially be one solution. I know that the time that was originally 50 minutes somehow rapidly accelerated and finished, though we didn't actually consume 50 minutes. But nevertheless, in the interest of the sessions, I will conclude. I think we have a lot of interest, there's a lot of opportunity, but this particular problem is something that needs to be solved right now, primarily because this is going to be one of the, I would say, sustainability imperatives, primarily because this is one area where you combine both mitigation and adaptation. So as your challenge becomes worse, you have to account for adaptation. Climate stress is real, it is live, and we have seen on number of heat days. And most people will tell you that when they were young in Chennai, you did not have air conditioners. I grew up in Chennai, I can vouch for that. But you cannot think, once you've been in an air conditioning environment, you cannot think of a situation where you're not in an air conditioning environment. The second thing I would also say is a concurrent problem of heating. Now we are starting to address heating and cooling together, but it's also instructive to look at it from the perspective that this is also a solution that can add more renewable from the grid, because this solution allows integrating storage along with it. And then this is an opportunity for all of us to look at. There is a session tomorrow on how do we integrate thermal energy storage into this whole ecosystem to use the grid, do the peak shaving, do it more effectively and better integration. And that's a solution that needs addressing on a much more stronger emphasis, because it is extremely low cost, does not depend on critical minerals, and it can be made almost as a demand side response metric. So you have great amount of opportunity. I really thank all my speakers here for sharing their time. We all will be around somewhere here. Please feel free to reach out to us. Thank you once again.